వాయిస్ కూడా అడ్డం ఉంది. ఇది కూడా అడ్డం.
अरे ఉంచుకోవడం నాకు వేరే ఎక్స్టెన్షన్ అమ్మాయి పడతాం సరిపోతాం నాకు తెలియదు నువ్వు వస్తున్నావు
స్క్రీన్లో వచ్చిన స్ట్రీమ్లో రావట్లేదు.
అప్పుడు ఇక్కడ ఒక లైన్
వర్క్ వచ్చింది సార్. ఇది యూట్యూబ్లో వస్తుంది.
మ్యామ్ ఇది సరిపోతుంది కదా
నేను ఇంకా ఆడియో క్యాప్చర్ ఏం పెట్టలేదు సార్. ఇంకా ఆడియో
డిస్టర్బెన్స్ అంత డిస్టర్బెన్స్ స్టార్ట్ అయినాక
అట్లా అంటారు.
ఇప్పుడు బ్యానర్ చెప్పాలి ఏం చెప్పాలి టేబుల్
అదే అక్కడ బోర్డు దగ్గర అటు ఇటు నడవ.
మైకే ఒకటి విన్నా
అరే మడి వస్తుందా చూడ ఒకసారి
మీరు ఇంకొంచెం యువతలు జరపచ్చా అది మిడిల్ కదా.
Kameswari. Welcome to 3-day FDP on AI applications in NLP and speech processing. Now I welcome the energetic HODs of youngest department of KMIT, Dr. Sridevi ma'am, HOD of CSCAML, Mr. Anil Kumar sir, HOD of CSCDS, onto the dais. I welcome Dr. Malliswari ma'am, Principal KMIT, to come on to the dais. Now I welcome today's speaker, Dr. Chiranjeevi sir, from Triplet, Hyderabad, and occupied. As per the tradition, let us start the program with lighting the lamp. I request all the dignitaries to join us in lighting the lamp. Esteemed colleagues and participants, it is with great pleasure and excitement that I extend a warm welcome to each and every one of you to our 3-day faculty development program on AI applications in NLP and speech processing. For the next 3 days, we embark on the journey of exploration, learning, and collaboration in dynamic field of NLP. Throughout this program, we will gain the necessary knowledge of AI and its applications, understand sentiment analysis and text classification problems, discuss on multilingual NLP, speech translation, and various challenges in linguistic NLP. I encourage each one of you to actively participate, share your insights, and forge connections that will extend far beyond the confines of the program. Together, let us embark on this journey with enthusiasm, curiosity, and a commitment to the excellence. Once again, a warm welcome to all the participants to the 3-day FDP on NLP. Now I request our beloved principal ma'am to just address the gathering.
Good morning, everyone. Sir, firstly, I should say thank you to driving us immediately you all accepted. We know that in triple you all are very busy, but in spite of that, everyone has accepted and everyone is ready to come and share your knowledge with the students. So, thank you so much, sir. On behalf of our KYD, coming to our students, about this FDP, my sincere request to all the students is update yourself with respect to the latest emerging trends. If you know better than others, your CV will be unique, so that every time you will have a better chance than others, like taking edge on others. So it should be like spot on. So I request everyone to embrace this opportunity, and whenever you have any doubts, you can get the clarifications immediately. Everyone is there to support you all. Thank you so much.
Now coming to the topic of today's session, which is the first session of 3-day FDP, Feature Engineering in Speech Technologies, Speech Science End-to-End. It's my privilege to introduce speaker of today's session, Dr. Chiranjeevi Erragaru obtained a BTech degree in EEE from NIT Warangal and MTech degree from IIT Kharagpur. He did his PhD on spoken language analysis from IISc Bangalore. During his PhD, he had received Prime Minister Fellowship for doctoral research. Prior to this, he worked as an assistant professor at KIT University, Bhubaneswar. Currently, he is working as assistant professor in Speech Lab Language Technologies Research Center, IIT Hyderabad. Welcome, sir. Chiranjeevi, sir, thank you so much for accepting our request. I request Chiranjeevi, Dr. Chiranjeevi Garu to take over the session.
Thank you, madam.
Anil sir, to welcome the speaker with the book.
Hello? Yeah. I can move around, right? No issues.
your mobiles in silent mode.
So good morning, everyone. Maybe let's things settle. So mostly, I'm trying to discuss this topic with the interactions. Okay. So hopefully, I will move around soon, right? So usually, you're going to face a lot of questions from my side, and I'm trying to explain those questions along with your answers. Okay, that's the whole plan. So before dive into the topic, so what do you think about Tribulite Hyderabad? Is it a government institute? Is it a private institute? What do you think, students? Is it a government or private? Private. So then who is the owner for that? So if it is a private, some entity should be there, right? To get the profits. Do you know who is that owner? So there is no owner for us. And it's neither private, neither government. We are completely public funded. That means we raise our institute from our own funds as well as from the students. And we don't have any profits, loss. Right? So this is the, I hope you know it, history of the Tribulite. This is the first institute based on this public funding, neither private nor government. So we're going to raise the funds. Okay? So that's the reason the model also success. I don't know whether you appreciate that model, but these models are available only in US. So they borrowed the concept here and then try to use the model and show the success for 25 years. So recently I completed 25 years, silver jubilee, right? And this model already taken to the many of the institutes also. I think you know a lot of difficulties you had, and it came up with a similar models, right? So immediate question is, since this model is different, then do you know how to admit, how can you get the admissions into the Tribulite? So it may be covered in stock also. I'm just trying to give the hints. So how can you get into the Tribulite? So after bachelor's, do you have any? How can you enter into the Tribulite? I mean, before bachelor's, it's a clear process. So you're going to get you're going to write the UG exams from institute side, IIT mains, IIT JEE mains, right? And what else? After bachelor's, is there any chance to admit into the Tribulite Hyderabad? What are the ways, if you are passionate about coming to the Tribulite, do you have any ideas for how can you come? How can you join Tribulite? If you are passionate about research, there are two ways. One is through the normal entrance exam, PCE, and another is through the standing committee. That means if you are keen on your research, your advisor found that you are eligible to do the research, then we can suggest the student to do the masters or PhD. So standing committee means the faculty advisor going to be do some work with the students who are in bachelor's time, and if the student works well, then the faculty can suggest the student for MS or PhD. That is the standing process, standing committee process. Another process is write the exam. We are going to have the formal interviews, and then you can admit into the reply. So why I am saying is that if don't aware of this standing committee, please think about it who are wants to do the research, pursue the research in future. Okay? And immediately you can approach some other faculties in IIIT for your internships, anything. Either through your faculty or directly approaching the faculty in IIIT. You know? So let's get into the talk. Future engineering in speech technologies, speech science to end to end. Probably everybody knows AI, ML, DL version, right? You are very passionate about it. Or no? Why you are interested towards AI, ML, DL? Emerging technologies. So currently AI, ML, DL are emerging technologies. So the question is, can these emerging technologies solve any problem? Can these emerging technologies can solve any problem? Or something required to know? Let's say you have some black box model from machine learning, deep learning. So with a pulling large amount of data, right? I think emerging technologies, current emerging technologies of TL require large amount of data, whatever the task you want to do, and pull the data and build the model. So that is sufficient. Or you want to know some knowledge of anything. Yeah, so please open up. Do you require, if you pull this lot of data, that's sufficient, or do you require any knowledge? Require knowledge. So where this knowledge goes? We require knowledge. Your friend is saying, I agree with his point. So where this knowledge should go? Did you heard about end-to-end models? How many of you heard about end-to-end models? Okay. How many have heard about Google automatic speech recognition? Yes, sir. Yes, sir. Okay, that's it. One person. Okay. How many of you using voice assistants? Siri, Google Assistant? Only few? I think I thought many of you would use that, right? So, in your voice assistants, what are the technology you are seeing? Has two parts. One is it tries to recognize what you are asking. That is automatic speech recognition, which is currently end-to-end. And second one is NLU, Natural Language Understanding Systems, where it tries to understand what you have asked. There are two parts. So that means you are unaware of end-to-end models. You are final year students or third year or second year, okay. Any final year students here? Okay, fine. So you said that knowledge is needed, right? So that knowledge should go to the first part, that is feature engineering. And then from there we have to build the models of ML, DL, or end to end. Okay? So how this knowledge should be taken forward in speech, that is my today's lecture. So I hope I'm keeping the concept very clear here. So how a future engineer knowledge, because knowledge, that means physics knowledge, to build any technology, right? So right now I'm focusing on speech technologies, that's all. Otherwise exploring many knowledge is too much. So I'm going to show whatever we are perceiving, which is easy to understand, right? We are perceiving, we are producing speech. We are perceiving, we are producing the speech, right? So everyday life we are doing that. And it's a natural way of communicating to the people, right? So that's the reason we choose how this particular aspect, the knowledge in this aspect, can be transferred to the future engineering. That's the reason I mentioned science, speech science. So knowledge is from speech science. So typical models like initial models to final deep learning models. Right? So I'm just going to cover, these are the few things which I'm going to cover. Just I'm going to try to introduce why knowledge is needed. I mean, some of you are already mentioned that, but I'm trying to show more specifically why this knowledge is needed in the introduction, that how the knowledge in the speech is inherited, and then that can be converted into the some kind of featuring AI based, and then end to end, right? It's not. So how many of you know detection concept? Detection. See, on this slide, whatever I'm showing is the cats and dogs. Let's say I would like to detect, our machine would like to, we would like to train the machine to detect cat versus dog. Oh, sorry, cat versus dog. As a humans, we can detect. Let's say you are building the model of detecting. That means if you provide the image of cat, the machine has to say that it is cat. If you provide the image of dog, it should be detected as dog. How to build this detection task? So some features, okay. So we are going to deduce a facial features, right? And after that, so let's as a humans, what are the features is required? Can you tell me? Ears, mustache, then two features. Eyebrows, okay. Then, as a humans, how can we detect cats versus dogs? But only image. With images, right? No images. Shape, face, shape, then size of mouth, right? So so many features, you know, to detect cat versus dog, right? That is how we are doing now. Then let's, from this image, somehow you extracted this information, right? And decided these features. Okay. So whatever the features you are saying, it's going to be listed out. So one feature, two features, 3, 4, 5, so on, right? So we are going to have so many features, right? So from the human knowledge, we try to extract these features, right? And then build a feature, right? Then after that, what we will do? So humans will pass those information to the brain and will detect it. That's very simple. But machines are not like that. We need to train the machines, right? What are they? What to build immediately? Hmm? Sorry. We should train with the models. So next step is these features should be trained with the models. What models? The model purpose is what? Here. You want to recognize image or you want to detect the cat versus dog? So we don't want to recognize the image, okay? We want to just classify the image. We don't want that. See, the image recognition is much larger task than the detection, right? If you want to detect cat versus dog, just you are going to compare some features. But you want to recognize all the dogs, right? All the cats, it's very difficult task. So easier task is to detect image, right? So to get that image, what models we need? So we need to have an image detection model. What models should be incorporated? Classification models, right? So that means we are going to build a classification model, right? Taking these feature vectors. So we are going to train, we are going to pass this to a classification model. So we'll pass this feature vectors to the classification model, and next step, so we'll train the classification model, right? Then what will you do? So we train the classification model to know the cats versus dog, right? So what is the next step? Testing. So during testing time, we are going to provide a cat or dog image, and classification model predict what? Classification model predict what? Directly detects cat or dog. Any other idea? Directly will detect as a cat or dog, or something else is going to happen. What it will do? Directly will give cat or dog. There's something we should do. So give the percentage how much that image belongs to the cat or dog. So instead of percentage, I am putting the term probability, right? So it gives the probability of whether that image is cat or dog, right? So from the probabilities, it's your decision, right? So whichever be the highest probability, you are going to consider cat or dog, right? So during the testing time, we are going to have probabilities, and those probabilities we are going to use. Probability of cat given feature vector x, or probability of dog given feature vector x. This is my x, right? So this is the typical problem of detection task. So any detection can have a classification model, and these features can be obtained from your knowledge or incorporating this knowledge to the certain models. Okay. So today we are going to see what kind of features are important for speech technologies, right? So, as already mentioned that we need to enter some information, right? Now the question is, as the humans, you know that we need to enter certain information which is relevant to the cats and dogs class, right? Generically, what is the feature? How do you define the feature? It is independent, okay? How do you define the feature? So you mentioned 5 features, right? Your friends have mentioned 5 features. How do you generally define the feature? Okay. So some characters, distinctive features, distinctive information that embedded, right? So typically that is the dictionary definition. So we need to find a significant information which attributes for your task, right? So in this case, cat versus dog, you are finding kind of significant information which can do the task of cat versus dog, right? So it's not only confined to cat versus dog, it can feature is confined to whatever the task you are doing. So always based on your task, you should think about the feature which can provide the distinctive information to do your task, right? Now coming to the next step, what is feature extraction? You already mentioned that there are some features, right? So how can you say that what is the feature extraction? So what it's doing? Transforms your raw data. So right now for the cats and dogs, the raw data is image data, right? That image data we are converting to the some kind of numbers, right? So maybe one case is for cats as dog is ears are in this shape, 1 or 0, right? So is the mouth is tall, it must exist or not, like that, right? So you are converting your raw data into some kind of numerical features. That features we are going to use for further analysis. And as you know, if you don't extract the proper information, it's going to spoil your model. So you need to extract the right information. As humans, what we are doing, similarly, machines also should learn if there is information. If there is no information, it won't, right? So it will yield better result when we are applying machine learning techniques. So I'm going to highlight 2 points here. Feature extraction can be done manually or automatically. Any questions at this point? Okay. How to find manual feature extraction? So as you already mentioned, we are going to identify describing the features which are relevant for our task. Okay. Don't forget the task. Always task should be the problem in our mind. So for a given problem, you should extract. It's not like independent of the given problem. So you should have a good understanding of the domain. That means for the cat and dog problem, you should have a clear understanding of how cat look like, how dog look like, right? So from that you came with some kind of feature. So same thing here. So similarly, how can we do automatically, right? So most of the cases we are lazy to learn the knowledge, right? That's the reason we want already existing models, right? And that's the reason nowadays it's popular also, right? So we just use the models whatever existing, right? But still, instead of relying on the knowledge, how can we extract the features automatically? So for the school feature extraction, again we should have some specific algorithm which is not arbitrary. Again, that specific algorithm should be extract the features based on whatever the task you have, and from that we can develop the ML models, right? So please active, okay? So let's go to the speech. So you have so many technologies, right? Out there. So let's say your chatbot. How many of you know the chatbot? Good. How many knows the voice assistants? Siri and Google. Good. Right? So which one you would want to prefer to communicate? Chatbot, okay? Why you want to communicate with the chatbot? Why you want to prefer to communicate with the chatbot? Faster replies, okay? So if both are at the same level, that means speed of your voice assistant as well as chatbot, both are same. Which one you would prefer? Chatbot, okay? Voice assistant. That's it. Which one you are going to prefer? Chatbot or voice assistant? So I think voice assistant means you are going to ask the questions through speech. Chatbot means we need to type the question and it will reply, right? So which one? That's it. Chatbot. But if both technologies are good, let's assume like that. So right now there are limitations in the technologies. I agree with that. But if both the technologies are similar, that means both are effective, both are responding nicely, then which one you are going to prefer? Voice assistants. Anything? Anybody? Which one? Chatbots or voice assistants? Chatbots. Okay. So why voice assistants? Simpler. We just have to talk, right? So for chatbots we need to write. So typically we are lazy people, right? We don't want to type, put the efforts to write, right? So naturally we are going to communicate, right? Naturally we are going to communicate with speech. So same way of communication we want to expect from the machines also. Not like typically writing the questions, it will take a lot of cognition, right? When you write the typing, it takes a lot of cognition. When you speak, no, it's naturally it comes out, right? So always when the technology is there, we would like to prefer using speech or talk to the machine than the typing, right? So it's a natural way of we are communicating, how we are talking to the friends, right? Same way we are expecting we should talk to the machines, right? We don't want more cognition to be utilized, right? So that's the reason. Let's see. Since the speech is always we want to communicate, so can we have understanding behind the speech behavior so that we can develop the feature engineering for speech technologies. Okay? So how we are producing the speech? Anybody? Any idea how we are producing speech? See, we grown up, but without knowing how exactly we are producing the speech. You know, it's a nice coordination of our brain. It has a lot of coordination which we are explicitly don't learn. Implicitly we learn. You know. But now I'm going to discuss how the speech is produced explicitly, and that how it helps to do the feature engineering. Right? So So this is just igniting your thought process. How you produce the speech? Vocal cords. So how many of you know vocal cords? Okay, good. So vocal cords are these. Right? If you touch it, it will vibrate. If you speak, it will vibrate. Right? So it's a voice. It will vibrate. You can sense that vibrations. Okay? Only vocal cord is sufficient. Only vocal cords are sufficient. Tongue, mouth, okay? Teeth, lips, right? And tongue, mouth, lips. Cognition. So I'm just taking the answer of brain towards cognition. You need to have cognition, okay? So I'm putting the terms for this. Lips, tongue, teeth, jaw together as vocal tract. So it is a process, right? Then, so you need vocal tract, you need vocal cords to vibrate, you need cognition to send the information. What else you need? You are missing something. So let's see how the speech is producing. Let me play this audio. Just observe carefully. I'm going to ask the questions again. Audio. Audio is not.
Audio is not. Sir, same. ఆ వీడియో చేస్తాను.
The air coming from lungs goes to the vocal cord, right? This is the vocal cord, and there vocal cords vibrates. Then, because of the vibrations, you're going to see pulsating like output, and that output pass to the your articulators, right? I mean vocal tract, because different shapes you're going to get the different sounds, right? So how the wave look like here? How the wave at end of the mouth looks like? How it looks like here? Let's see here. See, there is no vocal tract is moving, just simply passing. How it looks like? The air comes, it's pulsating, and that's coming out, right? So without the air movements, you cannot perceive, do you? Without air movements, whatever air medium in between us, it should move to get the speech from my side. Otherwise, you can't perceive, right? So how that air is moving? How air is moved? What kind of wave is that? Longitudinal wave. It has expansions and contractions in the air molecules that will touches your eardrum. That eardrum converts your that pressure variations into the information what you want to decode. So here, whatever you are seeing here, this is contraction. This is the expansion of the air molecule, and that is how you are getting information from my speech. So you are going to have then like this. So there is a pressure variations in the air. That pressure variations will touch your eardrum, and that will convert into the some kind of information what somebody said. You are going to decode it, right? Okay. Let's now, if I am going to draw like this. Have you ever seen the signal? How many of you saw the signal, speech signal? Have you ever recorded with your microphone and saw on your laptop with different softwares? So I think you are going to see like that, right? That waveform, not like what we are perceiving, what exactly is passing to you. So mostly always the music pulses will up and down like this, not like in a longitudinal manner, right? So what is the relation between this? So that waveform, how air is passing to you as well as what you are seeing in the software. What is the relation? Anybody knows? Not science, but some variations. Right? It has some wave there. Correct? But what is the relation? Just I'm asking. Since what the question is, we convince that the speech reaches you through the variations of air particles, right? Pressure variations, and that touches your eardrum. But in the software, what you are seeing is not like that. It will be some kind of waveform, longitudinal waveform, right? Right? So some kind of this kind of waveform. Am I correct? So what is the relation? Do you see that relation? Is there some magic? Is there? No magic. Simply one thing. Right. So friend is saying that if the compression is higher, then the peak is high. If expansion is higher, it will be lower negative. Right? So how that can be related to this waveform? So when I am speaking, the air pressure changes, it will touch your eardrum. So assume that eardrum as a point in the space. And to that eardrum, how it will give going to move? Front and back only, right? Do you see the eardrum movements? So whenever pressure exerts on that, it will move based on the pressure variations, right? So if you see that eardrum as a point and the pressure variations, if you draw it, that will be this diagram, whatever you are seeing on the software. So right now it's in the 3D space, but when it touches your ear, it is 1D space. That's the difference. So it's a one point in this entire 3D space, the eardrum. And how that eardrum moves is the whatever you are seeing on software. But what exactly I am producing is like with the this kind of compressions and expansions on the air particle in the 3D space. That is the difference. Right? So why all this story? Because I am going to show most of my work. I am going to show this diagram, not this diagram. That's the reason. Right? So I want you to understand that how we are producing, how exactly we are seeing from the softwares. There is a difference. So now a lot of ambiguous questions I'm going to ask now, right? So this is the text. You enjoyed it. The text is you enjoyed it. You know, and this is the signal what I just now talked about. So whenever I say you enjoyed it, your eardrum going to be observe the pressure variations like this. Okay, so y-axis pressure and the x-axis time. With the time, these kind of pressure variations going to be observed when I say you enjoyed it. That is corresponding to signal 1 and signal 2. Two signals. Two are for the same text you enjoyed. Now you are going to see the challenges in the speech. So when I say you enjoyed it, right? When somebody else say you enjoyed it, you are going to perceive it as you enjoyed it, right? There is no ambiguous here. Same thing I plotted here. So whatever first one is the signal from person 1 and second one is from the person 2. How many of you see the correlation of the signal, pressure variations? So when you perceive, it's very wonderful. We are able to see that you enjoyed it, and we are going to perceive it, you enjoyed it. Whether you are saying, your friend is saying, right? We can see that. But same thing, when I draw it on the software, that's what computer will see. What our task now? We need to make sure that whatever we are how we are understanding, we need to make sure that computers or machines should understand like that. Right? So now you tell me there is a signal from the software for the one person is speaking. There is a signal when person 2 is speaking. What is the similarities? Anybody can pinpoint some similarities there on the two waveforms? Because that is what your machines will see. Now you need to see and tell the machine this is what you need to look for. Otherwise they won't learn. They are random. Right? They are much lazier than us. Because if you don't train properly, right, it will learn something what it was interested. What is similarity? Any similarity? Anybody found? Pressure variations are there, but similarity in the pattern. Any pattern. That means when I say you enjoyed it, always it's same. But when you see any pattern is there, that means any relation is there between the top one and the bottom one. Any relation? No relation? Then how machines will understand? Any relation? So repeat once again. have some point which is valid. Now I'm going to discuss that. You know. So let's take few things before we are diving into the what kind of patterns we are going to see. Let's a male person is speaking, you enjoyed it. A female person is speaking, you enjoyed it. Right? So we are going to perceive, you enjoyed it. What are the variables of perceive in the speech? Male versus female. What are the variables along with the message you enjoyed? What you can perceive? So there is more information. Pitch it changes. What else? Bass. Bass. No pitch. Okay. Frequency. Yeah, pitch is related to the frequency. Okay. Something like that. Loudness. Loudness variation. What else? So already you are seeing there are variations you can see in the same message. Loudness, pitch, pauses. What else? So one more important also there. Accent. Okay, let's consider both the same accent. Stress. Okay, I'm not sure. Loudness is related to the stress. Okay. So one more point is time duration. See, duration, when you are saying this time you enjoyed it, next time if you say enjoyed it, you enjoyed it, it won't be the same length. How much duration is taking to produce the you enjoyed it won't be same. It will vary. So the duration also matters. Right? So these are the constants. Pitch varies, duration varies, loudness varies, all these things, these four parameters varies. Right? Then how do you see the pattern? But still we are seeing the pattern as humans. But in the signal form, not yet seen. How? So these pitch variations are going to be seen for a longer duration, right? For a small point, a small duration, it won't perceive much. And also how we are decoding, let's understand how we are decoding you enjoyed it. Let's say two people are saying how we are decoding the you enjoyed it the speech. Directly we are just converting or something is there process. What is our process? Human brain process. How we are decoding? What is step by step we are decoding as humans? Syllables, more sounds. So syllables is a bigger entity because as the Indian languages we are already decoded as syllables. But more precisely, we are decode the sounds, and the sounds we are going to map to the text. You know, so sounds will be there, right? So these sounds are very small duration compared to the complete you enjoyed it, right? So as humans, we are decoding these small durations into sounds, right? Similarly, we need to see the patterns not as a whole. We should see the patterns as in the small durations. Then only you can observe. So right now, whatever you are seeing, always you are focusing on the entire thing. But one of your friends saw some similarities in the smaller part, right? So, if you want to see the pattern and tell the patients to learn it, you should see the patterns in the small duration, not the longer duration. That's the one of the big major point in the speech knowledge. So, without seeing the smaller durations, you cannot see the patterns. So now, I am going to zoom the certain portion here. So here, for the top signal, from here to here, you, and here to here, enjoy. It, okay, this part. So it is this side. Similarly, the bottom one, here to here, you, enjoy, it, okay. Now I am focusing on one sound E here. Do you see any patterns? This ball within this black box. Do you see any patterns across these two? This is my sound E. Let me zoom it. Do you see any pattern? In the sound E, do you see any pattern now after zooming? What is the pattern? So it rises slowly and falls. Similarly, rises slowly, falls. So how a blue contour varies, how the blue contour amplitude varies is the pattern. See, here to here and here to here is the corresponds to the sound E. And the actual blue contour, whatever you are seeing, right, the complete variations, this is related to your voice. There are two things that what you mentioned, right? In the speech, there will be a voice, loudness, along with the sound message, right? So the sound message is this, and these variations are your voice. These are two aspects. Any questions? So, the major point from the speech understanding, how humans are decoding, we don't want to see the complete signal, we want to see a smaller parts. Small parts we are going to analyze, not a complete. So whenever, if you want to detect the task, let's say I'm saying cat, at the same time dog, right? You want to detect the cat versus dog from my speech, right? Then if you compute the features for entire speech signal on feature vector, then it won't work. What is the idea here is that you need to divide my speech of whatever I produce for the cat, you need to divide it into small parts, and each small part you need to compute the feature vectors. This is the first point for speech technology. Without that, you're never going to succeed. If you want to analyze the speech, you should compute the small levels. And with the small levels, you can compute the feature vectors and we'll use it. Any questions? Okay. I think all are computer science students. So Fourier transform is very well known in EC domain. So for you, it's very common. You know. But how many of you know heard about term Fourier transformation? Oh, good. This side. So Fourier transformation, you heard about it. Okay. So what is the main point from the Fourier transformation you can take? What is the main point? What you will do Fourier transformation? Any information you pass it can decompose into the sign. multiple signs, right? Each sign has the frequency, amplitude, and phase. Correct? Any sign signal has the three parameters. Correct? Are you clear now? Sign signal, just from your NLP math. How you are going to parameterize the sign signal? Frequency, amplitude, and phase. Right? So Fourier transformation, indeed, you try to tell us. You give any signal. It's not only speech, any signal you give it. You try to decompose into the what are the amplitudes, frequencies, phase of different signs. So why it is useful in speech analysis? Let's you are given with one problem, okay? You want to detect male versus female. I gave the male speech, I gave the female speech. You need to detect whether the speech belongs to the male or female. What is the how you are going to approach that problem? Pitch. Pitch is a frequency form, right? Pitch is how, what is the vibrations, right? How fast your vocal cord vibrates, that decides the pitch. Right? Vibrations are is equivalent to the frequency of that signal. Right? Vibration is going to be equivalent to the frequency. Right? So that means what your friend is saying is that male has a different frequency range compared to the female. Right? So that means you are going to find the frequency. Instead of seeing the how fast it is vibrating from the entire time. Instead of that, just simply what we want to observe, what is the frequency of frequency and what frequency that vibrations are going on. So if you find that one number, that is enough. Instead of seeing the entire vibrations for the time from some duration, long duration. We don't want. We just find one number, how much fast or what is the frequency of the vibrations. With the vibrations, we can compute the, we can detect the male versus female. So who will do that? Who will compute that? To the machines. Who will compute that for the machines? Fourier transformation. Right? Fourier transformation, whatever signal you are giving, you try to find its equivalent sign, frequency, amplitude, and phase. Right? So you try to find the, if you apply the Fourier transformation on the vibration signal, right? You can get the frequency. So from the male voice, for the vibrations, you can pass the Fourier transformation into the frequency. Similarly, for female voice, pass the Fourier transformation into the frequency. You can compare those two frequencies and decide that whether it is belongs to the male or female. Clear? Or in ambiguity? So then, so I can tell you. if I want to indicate this sign to the computers or to the machines, is it sufficient to tell that A0, omega naught and phi naught, or do I need to show the entire variations of machines? What do you prefer? So if you tell the machine saying that it's a sine with an amplitude A naught and the frequency omega naught and phase phi naught, then it's sufficient. It will understand. No need to show all the time that how the variations of your values of the amplitude from minus into plus. No need to show that. Just tell the machine, inform that it's a sign in the parameter of this, then automatically you can sense it. Right? So same thing, if I'm going to plot it in a different way, how we are going to show to the machines, same thing now I'm going to plot it. What I'm going to show it is A naught and F naught, omega naught and phi naught, right? So, what exactly I'm saying to the machines, I'm trying to see. So, if this axis is my omega and this axis is phase angle and this axis amplitude, right? So, how exactly we are informing the machines? In that 2D space, 2D space. I'm just saying A naught, omega naught and phi naught. If you inform the machine, then it can understand. So same thing I'm trying to show or trying to understand in the plot. So there are two plots I drawn there. Both x-axis omega, both the plots. But y-axis for the top plot is amplitude, y-axis for the bottom plot is phase. Then how exactly we are informing in pictorial to the machine? For the same thing, A naught sin omega naught dash 0. Anyway, see the plot. So to ignite your thought process, I'll ask one question. So I want to plot the A naught sin omega naught be 0 in those two plots, right? It's a sine, right? What is the frequency of the sine in that expression? What is the frequency? I mean, angular frequency. What is the angular frequency in that expression? Omega naught, and at that omega naught, amplitude is A naught, right? So let's take another angular frequency, omega 1. What is the amplitude for this expression? No, don't generalize to the A1 sin omega t 0. Okay, I'm just saying for this expression A0 sin omega naught t plus 0. What is the value of amplitude at omega equals to omega? A naught, okay. What is the amplitude at omega equals to omega naught? A naught. What is the amplitude at omega equals to omega 1, which omega 1 is not equals to omega naught? What is the value? Huh? See, I'm just asking nothing. I'm very simple on something. I'm trying to see your expression in the plot. Whatever you understand. So, a sine signal is a frequency omega naught, amplitude A naught, and phase 0. This is what I want to plot. Right? So you are right. When omega is omega naught, amplitude is A naught. I'm happy. But what is the amplitude for the same sine signal A0 sin omega naught t plus 0 and omega equals to omega 1? omega 1 is not equal to omega 2. What do you say? So I'm just trying to put your answers here for the amplitude, right? So here omega naught, right? And you mentioned that amplitude value is A naught. Now my question is, if omega equals to omega 1, what is the amplitude? For the same equation. It's a lot of amplitude. Is that omega 1 angular frequency exists in that equation? So what I'm asking is, what is the amplitude of sine signal with omega equals to omega? But we don't have that signal, right? We have only one signal with A naught and W naught. We don't have another sine signal with another amplitude and with the angular frequency omega equals to omega. So then what is that? 0. Right? So similarly, another angular frequency, right? What is the value? So for the same thing, for the same sine signal, it always 0, except this location. It will be 0. That is how machines will see. That is how we need to send the information to the machines. Now verbally, if you say it won't understand, right? We need to show something, right? So whatever verbally we said to inform the sine signal, but now certain form we are sending, right? Similarly, can you tell me the second diagram how it looks like? See, for this, you don't require any engineering knowledge, okay? Just from plus 2, whatever maths knowledge, you just ask. Right? So, for the second one, where the final phase angle is 0, what is the plot? What is phase angle value? 0. Right? At what angular frequency? 0. Right? That's all. It's a 0, right? The complete 0, right? The phase angle is 0 for all frequencies, all angular frequencies. Then, if you pass this two information, then your machines can understand. Otherwise, it can't. So another tricky question: if the phase angle is phi naught, then how the plot looks like? If the phase angle is phi naught, how the plot looks like? If the phase angle is phi naught, not 0, right? Then how the plot look like? Parallel to x-axis. Your friend is saying it's parallel to x-axis for all frequencies. What is the value here? Phi naught. How many of you would agree? How many of you would agree? See, you don't worry. I think this question I keep on asking my students also in different kind of. So these ambiguities exist. Don't be afraid to, if you have some thought, you explore or express. Right? You don't worry. Same ambiguities will come from all students so far I taught, even in the lectures also. Right? You don't worry. So is how many going to agree in that? It's parallel to the x-axis at the location final. Is that correct or wrong? So same way, how exactly you have thought about this plot, same way you need to think about it. So for this plot at omega naught, amplitude exists, and remaining angular frequencies, the amplitude not exists, right? Similarly, here also, for omega naught, phi naught is exist, and remaining angular frequencies, it won't exist. So again, it's a similar plot. It's not exactly parallel. It will be at the omega naught, this will be exist, and remaining all is 0. So where this will be phi naught. Any questions? So whatever the plots you are seeing here, this plot and this plot, is going to be obtained when we pass this signal to the Fourier transformation block here. So whatever be the machines need to understand, need to able to process easily, can be obtained by passing this time domain. This time domain sign, we pass to the Fourier transformation, we can get this information. And this information, machines easily understand and effectively can process. How many of you understand? Everybody? Then I will ask another question. Okay, next question. So previously you understand we need to analyze the speech, small information. And we also understand when you process in if required as kind of frequency information, not the alright. So frequency information we can obtain in the Fourier transformation. Now what is the need for short-term Fourier transformation in speech? So if you are able to answer, then I am happy. So what is the need for short-term Fourier transformation? I kept the bullet point here, right? Short-term Fourier transformation. Why do we need that? Why do you need that? Short-term Fourier transformation. No idea? No? What is the meaning of short term then? Within the less time, within the smaller durations, right? Short term. What is the need for Fourier transformation? To see the frequency information instead of directly seeing the value information, right? What is the need for short term Fourier transformation speech? Let's say you are analyzing male versus female voice. Okay? So let's say now the question is a bit complicated. I have the speech contains some portion is from the male, some portion is from the female. How do I identify? Which one? Which to which is male voice, which to which female voice? How do you do that? Tell me your ideas. How to, but the frequency, you need to pass entire signal, no? See, to get this diagram, you need to pass entire signal, entire sign, then only you can get it, right? Right? But it's a general problem where your speech contains certain portion is male voice, certain portion is female voice. How to do that? This is a common problem. What we are facing. We are using voice assistants, everything, right? This is the challenges we are facing. We are doing. This is a very simplest problem in the speech. You have a speech, that means I am speaking. Immediately somebody female speaking, right? And that speech I gave to you, and I want you to find the where my voice is there, where female voice is there. How to do that? So one thing we should know is that we need to get some frequency information. That is sure. What else? What else? It's a simple logic we have to think. How to do? As a humans, how we will do? Same thing later we'll ask for the machines. As a humans, how we do? From here to here, male voice or female voice. Let's do the same thing and create the audio. How do you, as a human, you are going to detect it? Change in pitch. So how do you observe the change in pitch? How do you observe the change in pitch? Yeah, that's valid. Change in pitch we need to identify. But how do you observe? How we are observing the change in pitch? Increasing, reducing the values in the pitch, right? But further, how exactly we are processing here? We are finding that increasing or changing, reducing in the pitch values, right? By perceiving. How exactly we are perceiving that change? At what level? How? It's a complete signal with have the two variations in the pitch, right? How we are processing as humans. You miss small point here. If you understand, we are processing the information in smaller durations, then why you are not thinking for the same this task also, we are going to process the same smaller duration, not the complete durations. I mean, if your convince the argument that as a humans, we are processing the information to the smaller durations. So for the male voice and female voices, we are also doing the same way that we are going to process the small duration. That means in this small duration, what is the frequency or what is the pitch, right? Is that pitch is the male belongs to male or not? Like that, every small durations we are processing. I mean, if you convince in that we are processing you enjoy in text as small durations. Why you are not thinking this is processing in the small durations? What is the ambiguity? Do you agree or not? So if you process in small durations, finding the frequency, then we can see where the pitch change from, let's say we are going to divide this complete thing in small chunks, and which chunk to which chunk the voice is changing, that is the location where the pitch is changing. That's all. No need to completely observe the entire signal. Small chunks, find the frequency, and where exactly the one change is happening from one frequency to another frequency. Don't you see the problem? How I am approaching? Right? So this small, instead of analyzing the complete signal, if we analyze in the small, that is called short time durations analysis. You know, we are going to analyze in the short time durations. And the Fourier transformation, what it gives the frequency information. That's what we have shown, right? So if you apply the short-term durations Fourier transformation, you can get the frequency. With the frequency values only, you can get find the male to female voice changes. So the idea of short-term Fourier transformation is apply the Fourier transformation on small time durations. So if this is a complete signal, then we are going to divide it into the small units, and we are going to don't worry about this bottom figure, okay? We are going to apply the Fourier transformation to get this frequency information. So you don't need to completely see that. Small durations you can see. So now, what I am going to show you is that for the same speed signal, you enjoyed it. Now I am going to apply this short-term Fourier transformation. Means I hope you attend with that we need to analyze the speech in shorter duration, and to get the actual representative information, we need to use the Fourier transformation. Right? I am going to show the Fourier transformation for the you enjoyed it signal, whatever we have seen, right? Now you are going to see the patterns. I think I don't know if before it is visible or not. So these are the patterns. See, the darker ones is the pattern that is found by the machine. So here darker lines, here darker. And see the pattern here, it's going down, coming up. Similarly, going down and coming up. So within this U frame, from the signal side, you are not finding anything. But from applying this short-term Fourier transformation, I can see the pattern. Similarly, here you see the pattern here, same thing here, and what are the pattern here? Same patterns here. You know, this patterns, and you see going down, coming up. So going down, coming up. Enjoy. Whatever. So whatever you cannot see directly from the signal, the abdomen signal, as we inspired that frequency or some information we can gather from the signal. So if you plot it, then I can see the patterns in the same thing. Any questions?
Yes.
Any questions? No questions? Fine. How many of you heard about convolutional neural networks? One, few, okay. How many of you know that convolutional neural network has the filters? Okay, 2, 3. Okay, what I will do is that I'm just going to describe the second part. That is, so far what we have seen is that speech science, the behavior of the production, and how it can be incorporated in the knowledge to extract the features using the short-term Fourier transform. Two aspects we are seeing that, right? Short-term, that means we need to analyze the speech short-time duration because we are perceiving like that, right? And the signal, whatever we want to see, it's not worth to see in the time domain. We should see it in the using the frequency values, right? So that's what short-term Fourier transformation. So I'm just going to describe the what are the end-to-end models. Then I think I will stop. When you listen the word end-to-end model or deep learning model, what do you sense from that? What do you sense from the end-to-end model? What do you see from the name itself? End-to-end model means. What do you sense? No? No guess also? And to end. So from start to end, okay? So let's start with the your detection task only. So cats and dogs, image classification task, okay? So you compute the features, right? You have computed the features of whatever you mentioned, different categories, and then you are going to pass through a classification model, okay, along that, right? Then you are going to perform the task. So can we call this as an end-to-end? How many are going to say yes, or how many say are going to no? So you are going to compute the features. That means how the ears look like and how the facial features are look like, right? That means if the ear is like this, yes or no? Is motion exists, yes or no? So and so, right? Then with that features you are giving to the classification mode and you are performing it, right? So can we call this as the end-to-end? Or else, what is the problem associated with this problem model, with this approach? Anything is fine, I'm happy to discuss. Let's say you compute the features and classification model and then you are doing, right? Is this everybody going to be happy with that model? If you do it like that. Huh? No. Why? Everybody going to be happy with that? Let's say at the back side nobody mentioned the features, right? Features are coming from this side only, right? Then are you agree that features are sufficient? So there are 5 features your friends are mentioned. Then I am going to build the classification model. Then can that classification model can reach the 95% of accuracy? What do you sense from it? Did you build any classification models or not? Detection models? Good. So this generally, I am not asking any machine learning question. It's a general logical way of understanding the problem. If your friend mentioned some features, do the classification, then that's all. You're going to submit your or there is no issues because you trust your friends. Fine? No ambiguity is nothing. That means it not result in the collaborative work. Simply, if you are taken as it is, that means your friend is not going to improve and you are also not going to improve. Right? The great work will come from great discussions and competitions, right? Great research work, I mean to say. So if you accept your friends, what are the features suggested? Okay, then it's not a great work. No? Nothing? So in this room, there are 10 fans. How many of you agree with my words, or how many of you are going to agree with my words? In this room, 10 fans. Yes or no? No. Yes. Huh? No. Why? Huh? You should check, right? So you should at least use your knowledge to check indeed my points are right or wrong. So same thing, if somebody suggested 5 features, how do you agree upon? Did you check? First, at least there should be an answer come from you saying that I want to check how much effective the features are. Just simply copying assignment kind of thing is not here, right? It should come from your thought process that how do you justify that your friend suggested features are valid or not? Right now you said that you're not going to agree there are 10 because you want to cross check. At least you should have an innate your thought process to cross check indeed those features are effective or not. Right? So again, going back to my question, features and classification model. If the friend suggested 5 features, can we achieve good accuracy, effective accuracy? No. Why? So many features will be added. Right? So the features, whatever your friend suggested, is not exhaustive to do the task. There may be some features which are going to be important to perform your cats and dogs classification task. Agree or not? Always, whatever be the features, may not be exhaustive. Right? That is the whole point and whole motivation for the end-to-end model. So in the end-to-end model, we don't rely completely on the handcrafted features. Whatever right now we just saw that, right? 5 different handcrafted features. It won't rely on that. It will take the information from the image, from your knowledge. So how exactly? You are going to say the machines to learn or extract certain features, particularly focusing on the face. You are going to instruct your model to learn that. Then what kind of features should be effective for your cats and dogs class? Classification task? The model will learn. Not you. Not you directly provide the features like a handwritten. It will be learned. Right? So what we are, as a designer, our duty is inform where to look, how to look. Not like finding the features. So look here, find the features your own. Measure, you do it for this task. I don't want to interfere. That is what end-to-end modeling does. We don't extend the features. So as your friends mentioned, from start to end, there is no human information, human handcrafted information should be there. And humans should not compute the features and do that. Everything going to be modeled by your machine, but with the knowledge of what to look for. That is most important. Right? So that is the difference between traditional models like extracting the features and using the classification model versus end-to-end classification model. So in the cats and dogs class, just I'm going to pass the image, right? I'm going to have some neural network models, and we are going to suggest the neural network model. You should focus on this part, okay? And then build a classification model for cats. That's the whole end-to-end. So same way we are going to do for the speech technologies. I think I will stop it here, right? So any questions either now or offline? I'm happy to address. Any questions related to the admissions to the reply when can you start the internships? Any general questions related to the how to get the admissions to the reply internships, further programs, or whatever the discussed today. Anything I'm trying to discuss. Okay?
సార్ కంప్యూటర్ వెనుక
Kindly don't say no.
I think that's
Ma'am will pass the mic. Will pass the mic.
Being from a non-technical background, I have so many doubts. I guess you should be having doubts. We pass on the mic. Any questions? The boy has a question.
Sir,
yeah.
sometimes we try to give a command in other languages, for example, Telugu, etc. Then why exactly Kannada, like takes other words completely different.
Can you repeat?
When we give commands for voice assistant for some tasks, sometimes if we give other languages other than English, we keep one day try to take completely wrong. Why is it?
So the speech technology, whatever we have, is more rich for English, and for Indian languages, not yet evolved. Right. So whatever technologies we are building, currently we are focusing on Indian languages. I think that's what Anil will discuss how the models are building for the Indian languages. So that's the reason the effectiveness of the models related to the Indian language are not on par with the English language. One is for English we have a lot of data and lot of available resources for the English languages there. But Indian languages we don't have.
Anyone?
Communication is important while anywhere in the world.
Communication.
So the language is important anywhere in the world.
Ah.
So here our problem is in India in different languages. but we have to communicate through different languages. Is it possible that if we come, if we want to uh, send a message, they should understand in different languages? If I am speaking in Telugu, they should understand in Tamil.
Right, so there is a lot of work is going on in under the DST, Department of Science and Technology, and AAA also in the great part that is called speech to speech translation. So that means one language speech is going to be translated to another language in real time, mostly in real time. So that these kind of barriers, whatever you are raising, going to be reduced. So I think recently somewhere, yeah, they use the whatever is developed tool under the umbrella of project called Bashi. So where that is actually part in the speech as well as machine translation. So that's what going on. And all the, as a part of this project, all the education content which is in English language are going to be translated to the Indian language also, so that this language barriers could be overcome.
So you have spoken about internships in civil IT. Could you explain the procedure how to get it?
So one is you can approach the faculty to under whom you want to work based on your area of interest. And in this kind of problem, I would like to work on this kind of hypothetical thought. I would like to work on, and this kind of area I would like to work on. You can decide, and then you find the faculty who is working in that area. Then you can approach through your faculty to the other faculty to whom you want to work on. Or else directly write an email to that faculty and write it to whom you want to work with. So then they will reply. So main thing is that we are going to get so many mails like that, so you need to keep on write very good mails showing your interest in the faculty. Then they will reply.
I wanted to know that this is from speech to text, right? But we can also detect which language we are speaking. This is possible. Why not the barrier is?
So what you are asking is that whatever be the feature engineering I am saying is only for speech to text or is possible for language identification. So it's whatever I discussed is generic feature engineering for any speech technology, not based on the only for the speech to text. So this is the fundamental way of approaching the representing the speech or getting the feature for any technology. Like, let's say you want to identify the language, you want to translate language one language to another language speech, you want to create the text from the speech, you want to generate the speech from the text. All these involve this kind of engineering. This is a fundamental engineering law for feature extraction, whatever I discussed.
What are the factors of problems that are facing for converting into other language rather than it's only of kind of data for any other matter? Because
So converting one language to another language, for example, for the Indian case, right? So our structure, grammatical structure is different than the English grammatical structure, right? So it's not only the detecting the text, it's also translating the text from one language to another language, which our grammatical structure is completely different from the English grammatical structure. So if there is a closer relation between these structures, then the effectiveness of translation could be much better. If there is no structural dependencies, then it will be less effective.
I think it's my personal opinion that not all languages are important in converting. Sanskrit is mostly
So that is the, I think 5 years back, so our Indian speech is also thought like that. They're working on like that. That means identify the Sanskrit and Sanskrit to other languages because all are evolved from Sanskrit, right? So that's what they did it. But the problem is the Sanskrit, we don't have much data. That's the bottleneck there.
Anyone?
Sir, nowadays many chatbots, speech bots have evolved. So do you think we have reached a saturation or there is much more to come?
So there is no saturation at this point. Okay, and never going to happen also, I hope. So speech research started 100 years back, and still we are not in a position to address all the applications which is needed for the speech-based. Speech as a mode of communication to build the application. Okay. Only what we have reached is the speech to text recognition and text to speech. And there are a lot of more works are there, like for example, detecting the emotion from the speech, detecting the depression, whether the person is speaking is depressed or not depressed. So many problems are there. It's not saturated. Even in ESR also, I think somebody just now mentioned why Indian languages are not effective. No? So still, even in ESR also for Indian context, it's not saturated. Oh, it will take a lot of time. Maybe 2 more generations.
So, sir, while using voice assistants, one of the major problems we face is the model mistakes one word or another. So, how do we increase the efficiency of the model? So, do we use Fourier transforms and increase it, or do we does it have any other specific methods?
Can you repeat? I didn't understand the first part of the question.
So, while using voice assistants,
Why we are?
the voice assistant,
Voice assistant. Okay.
like Alexa saying, the main problem we face is that model assistant mistakes one word or another word. So how do we overcome that issue? Like, does it also happen using Fourier transform, shorthand Fourier transform, or does it separate with that?
See, the errors because of further process. That means after short-term Fourier transformation or short-term analysis, you are incorporated, right? Then later models are not able to decode the word properly. That's the reason errors are coming. Not because of representation is wrong, right?
Anyone?
Okay, thank you.
Please sit down for 2 minutes. Thank you so much, sir. I extend my sincere gratitude to each one of you for your enthusiastic participation in the first session of our 3-day program. I would like to express my sincere, heartfelt appreciation to our esteemed speaker for sharing his insights and passion for NLP with us. Actually, sir, he did not just explain the concepts. Along with the videos and visualization, he explained so that we got a clear idea Speech, while speaking, you can hear, but system, how it can recognize? The way, a clear idea we got such that we can do a lot of things in this. I would like to express my sincere thank you for your engaging presentation, sir. It set a strong foundation for the days ahead, inspiring us to delve deeper into the concepts of NLP. Thank you, sir. To all the participants, thank you for your active engagement, thoughtful questions, and willingness to contribute for the discussion. Your enthusiasm and eagerness to learn have created an atmosphere of collaboration and exploration which is essential for the success of the program. If you are not interested, we cannot do anything. When you are interested, then only questions come. When you are listening, then only questions come. You can clear the concepts, whatever the doubts you are having. I also acknowledge the efforts of organizing committee for their meticulous planning and execution of the session. Your dedication behind the scene ensures that each session runs smoothly and effectively, and we are grateful for your hard work. As we reflect on the insights gained during this session, let us carry forward the knowledge and inspiration into the remainder of the program, and together let us continue to explore, learn, and grow in our understanding of NLP. Thank you once again to our speaker, participants, organizers for making this first session of the program a valuable and enriching experience. I look forward for the remaining sessions ahead. Now I request the HODs of AML and DS to please present the memento to the speaker as a token of appreciation. Sir, please. Give a big round of applause. Once again, thank you, one and all.
Can we have 6 to 7 students for a group photograph quickly? Yeah. Those who have asked questions can come forward. We'll just take a picture with sir. You come better. Come.
students, the session 2 starts at 2 o'clock, same place. Those who are serious to listen and willing to learn, please join us.
ఇప్పుడు ఇంగ్లీష్ వచ్చి
The next session topic will be RNN to LLM.